Good evening, everybody. Welcome to this live Tenant Farmers webinar, the first of 2024. My name is Robert Martin, and I'm the National Vice Chair for the Tenant Farmers Association. We're very excited to have Tom Talford here this evening. We welcome him back again. He is the founder and consultant of Terra Farmer, and this follows up on the webinar he did last in July 23. Trees are not the only way forwards. Simple steps to improving soil carbon. As I said, my name is Robert Martin. I farm at Carlisle, and this evening is kindly sponsored by Oxford Bank. They're the only UK bank dedicated to British agriculture, founded 2021 by bankers, farmers and technologists, and they provide a huge range of specialised lending products designed to support farmers in running their businesses and competitive savings accounts. And one thing that people don't realise is that for every £1 saved with Oxbury goes back to British food, farming and funds agriculture loans. And last year they reached total deposits of over £1 billion. So we're very, very pleased to have them on board. They are extremely positive about the future of agriculture and the huge opportunities available for the food and farming sector. So, as I say, tonight is going to be recorded, this webinar, and will be available on the TFA YouTube channel. So we do encourage you to pay a visit and subscribe so you can see what we've done in the past regarding elms, SFI. We did a really good seminar there with landlord relationships, and so please log into that and you will see what we're all about. So as I said, we're looking forward to this evening's presentation. We've got a lot of people logging on tonight. It's really sparked a lot of interest. So often we're told that the only way to improve carbon sequestration on farms is either rewild or planting trees. Tonight's webinar will offer a deeper dive into soil carbon issues. We'll hear from our key speaker this evening, who is Tom Talford. He is a consultant with Terra Farmer, and we just need to look at maybe things differently of how we manage carbon going forwards. A little bit about Tom this evening. He's based in Cornwall, so he's already admitted to me tonight that it's boys' ground, so we'll take no lectures from Tom this evening, possibly. Tom is an organic farmer, and he's worked also with livestock nutrition for the last 25 years. He farms 450 acres with his wife Nicola, and they've put regenerative and biological farming practice into practice, running with an Angus suckler herd and growing grass, clover layers, wheat, barley and peas by cropping. Tom's view on regenerative farming changed fundamentally in 2017 after working in the States with the father of biological farming, Gary Zimmer of Midwest Bioag. Passionate about the wide-ranging benefits of good grazing management, diverse cropping and soil health, Tom believes that regenerative farming practices offer a win-win when it comes to farm profitability, public ecosystem services and the wider environment. Following a short presentation from Tom this evening, we'll also be able to hold a question and answer panel. So all I'll ask you to do, if you have any questions, put them in the question and answer box at the top of your screen. We've already had a huge number of questions prior to tonight's webinar, so we'll be able to fit them in as we go along. Alongside the panel this evening is Mr. George Dunn. He's the Chief Executive of the Tenant Farmers Association. I don't think many of you don't know George, but he's been our Chief Executive for the last 27 years. Previously, he worked for the Ministry of Agriculture, and then he went to work for the CLA, which is where we stole him from, and we haven't let him go since. George has represented the TFA on the Tenancy Reform Industry Group, a member of the Tenancy Working Group in England, and he also represents TFA Cymru with the Welsh Government, looking at the Framework Partnership Group of Agriculture. More recently, he's also been invited to be a member of the Tenancy Working Group in Wales. He's a National Trust Specialist volunteer on land use and governance, and he's also a worship team at the Reading Elam Pentecostal Church. So, as I've already said, any questions you have, put them in the area at the top of the screen, and we'll pick them up as we go along. So, I think what we'll do now is we'll just move on to Tom. So I'll hand over to you, Tom, for your presentation, and we'll see how that goes. Thank you, Tom.
Thank you. Good evening, and thank you for inviting me back. The world of soil carbon measurement is and soil carbon trading is still a bit of the Wild West, but things are improving, and hopefully tonight we'll give you an insight to how we can measure the carbon, and maybe some practices which will help various farm businesses look at sequestering more carbon and farming in a way that is more profitable and has the long-term aspiration of building resilience through soil organic matter and maybe more suitable farming practice. The current situation within carbon is that there is a gradual understanding of how we measure and manage carbon. We put this slide up last year, but I think it's very important to reinstate that you as agriculturalists have a huge opportunity to put the genie back into the bottle, to rebuild the soil organic matter in our farming systems. We have some of the most healthy soils in the world through mixed farming and good agricultural practice, and the fact that we have rain. But for each 0.1 increase in organic matter, we have the opportunity to remove 8.9 tons of CO2 from the atmosphere. Carbon built in the soil can be built up and released, so it's not a fixed thing, it's not a permanent thing, but we can over time increase the soil organic matter. And this 8.9 tons for each 0.1% increase in organic matter are measurable increases, and each ton of CO2 equivalents is the tradable exchange. It's the net CO2 equivalents. And if you can show that you're increasing organic matter and offsetting your own business, so working with the balance of this, you have an opportunity to build resilience in your business, water holding capability, possibly reduced inputs, whilst having a tradable commodity within the soil carbon, if you can prove and verify these increases in the soil. But you can't trade what you can't verify. It's important for us today to explain how we are measuring carbon within soils, what we need to do to make sure that those figures are accurate, and then to indicate how with small changes that we can build organic matter and build resilience and a possible long-term sort of benefit to your business. But with all the farms that we're working with, an open-minded attitude to change is encouraged, because if you carry on with high tillage, high nitrogen, high impact fertilizers, you're not likely to build organic matter. But with changes in fertilizer policy, in tillage, in cover cropping or perennial cropping, there's a huge opportunity that we want to sort of encourage you towards. On the next slide, there's two markets for carbon. We're talking about the voluntary market. And if you look on the AHD website, carbon credits, CO2 equivalents are worth about £20 a ton. And this, over a period of time and over increased soil organic matter, can be very valuable on whatever scale farming you're working with. Depending on your soil type, we're recommending that you measure your soils every between 2 and 5 years. If you've gone from a high tillage system into a herbal A rotationally grazing system, you can probably have measurable outcomes within 2 years. If you're on a tillage system where you've been using reduced tillage over a long period of time, but haven't got the advantage of livestock, and maybe you're in a drier area, then probably 5 years is a better return on your investment, because it will take longer to increase organic matter in those situations. Similarly, light soils, sandy soils are much more difficult to build soil organic matter. Not impossible, but again, we have to look at fertilizer. We may have to look at different sort of nutrient sources to build organic matter within that soil, because there's very little to hold on to that organic matter once it's in the soil. But also within this process, if you're looking at this, you have to offset your own carbon footprint first. I don't want farmers absolving corporate responsibility at their own expense. So a good understanding, there's numerous toolkits out there, Cool Farm Toolkit, Farm Carbon Toolkit. A lot of supply chains have their own carbon footprint. So understand what your own carbon footprint is and take that away from any gains that you can show over soil organic matter, so that you've got an excess, you've offset your own business. And the market is developing quickly. There's opportunities coming along that hopefully we'll be able to discuss with you in the future, where you can manage and measure your soil carbon improvements and take those all the way through to market. And these opportunities are developing fast. And I'm hoping that, provided that we have a fair wind, these will mean that the Wild West calms down a bit, and we'll get a much better return for our hard work, and we'll understand the market as it develops down this line. Next slide, please. So quickly, the practices that we are encouraging farmers to use are well known of the five roots of regenerative agriculture, and please don't get put off by the term regenerative agriculture. It's in many ways it's a way of making your own farm more secure going forward. By reducing tillage, you generally cut costs, so it's good for the sustainability long term, and then exposes less soil to the air, so we lose less organic matter. Ecological diversity, that can be simply improving rotations, or maybe trying bicropping if you've got a market that will take that, and the opportunity to reduce fungicides, etc. Reduce harmful inputs. It should be not impacts. It's the same outcome, I guess. But I'm becoming more and more aware that prilled nitrogens and etc. are potentially one of the bigger soil carbon burners than we ever imagined. It's where we've got farmers going towards foliar or offsetting or mixing carbon sources with their nitrogen, or calcium with their nitrogen. We're getting larger increases in soil organic matter. So we're looking at reducing inputs that over time we're starting to show genuine improvements in soil health by steering away from them or using them more proactively. Maintaining ground cover. Every time a plant starts photosynthesizing, it's producing sugars, and it pumps down these sugars into the soil. That's how we get carbon back into the soil. It's an amazing process. The sugars that are pushed down into the roots feed the biology of the soil. So it makes logical sense. The longer the ground is covered, the more opportunity there is to push carbon back down into the soils and build soil health. So cover cropping and perennial cropping are really starting to show great improvements in soil organic matter and soil health over time. And then I guess the more controversial one is the integration of livestock where possible. Again, if you've got a farm where it really doesn't suit, the costs involved in reintroducing agriculture are probably prohibitive. But the sensitive engagement of integration of livestock, rotational grazing, perennial cropping, herbal lays, diverse cropping within the rotation are all huge positives. The ability to reduce synthetic fertilizers in those systems are genuinely very important to soil health. So there is an opportunity on the farm suitable for it to where livestock can be integrated. There's a huge benefit for the long-term soil health, and the more and more data we're getting, the more and more that we're creating a story that genuinely obfuscates the very poor image that has been created around livestock agriculture in the UK, where we have rain, we have mixed farming systems. Livestock can be a huge potential carbon mitigation tool. And I'm passionate that this is got across to the population, because it's much more environmentally friendly that we grow meats and milks in an environment where we can create better health outcomes, and we cut down rainforests and things across the world. We have a huge opportunity to integrate livestock, build soil health, reduce inputs, and have a lot better outcomes for our agricultural systems. Next slide, please. So very quickly, again, I think I've shown this before, but if you soil biodiversity in the west of Britain, where we get prevailing rains and we've got a lot more livestock-based agriculture, we have a huge amount of soil biodiversity. The soil carbon map can almost be overlaid exactly like for like. Where you have mixed systems, where you have perennial cropping, you have a huge amount of soil biodiversity, and this soil biodiversity is the tools that we need to rebuild soil health. So we have the toolkit where the blue soils are in the UK. And in many, where we've got the sort of medium soils, we seem to get a very good response to those situations. When I started out on these projects, I thought that the poor soils, or the soils lacking the diversity or perennial cropping, would be the ones that we could build organic matter the fastest. It's almost the opposite. Where you've got livestock, where you've got perennial cropping, you've got healthier soils, and they seem to be able to rebuild and build at a faster rate than certainly a high tillage arable system. That said, small changes can make a huge difference. But I put this slide up to reiterate that we have really very healthy soils on a global basis. Next slide, please. So what are we learning? We're encouraging farmers to look at their soil in a slightly different aspect. And this may be the animal nutritionist in me, but it's becoming apparent that the microbial community of the soil is very similar to an animal's rumen. And therefore that incorporating different parts of different crops and different fertilizers and different inputs have genuinely better outcomes for the soil. If we incorporate green crop manures, or maybe we graze cover crops with sheep, you feed the bacterial part of the soil, that you encourage the bacterial reproduction and give them a very wonderful food source. Likewise, if we want to increase the fungal quality of our soils, incorporating brown matter, the manures, the compost, the straws, incorporating these into the soils, and maybe feeding them a little bit to get them to break down if you've used a lot of fungicides. Feed the fungal networks. The fungal networks are amazing. They can move phosphorus. Even in some instances, they can help move water over a much larger distance than the root matrix within the soil. We now know that rotational grazing, grazing and rest periods within soil means that you're mimicking the sort of rotational grazing that the grasses have grown up with over the last million years, and they're very healthy for the soil. That the soil can put a lot more carbon back into the soil when it has rest periods, as opposed to persistent grazing, when you start to stress the plant and they have to cut off their root system because they can't feed the soil like they would normally do in a rotational system. We know that different plants help the soil. Buckwheat, clovers, oats have quite an acidic root exudate, which helps break the phosphorus-potassium bonds in the soil. And therefore, there's opportunities to use a bigger or broader rotational cover crops to mobilize locked up phosphorus within your soil. So again, there's opportunities to cut the inputs within your rotation by using different species to access nutrients within the soil. Obviously, clovers also help fix nitrogen. So a larger range of crops, or more suited or specific cover cropping, can access different nutrients or can sequester more nitrogen within the soil. We're finding that light, regular applications of slurry and manures are becoming more effective than heavy doses. This is a sort of an outcome that we're noticing from the umbilical systems going on a lot of dairy farms, is that with these extreme weather events, they get to a point when the farmer has to put a large dose of slurries on, but this quite anaerobic dose of a lot of nutrients, filling all the pore space in the soil has complications down the line. Whereas lighter, more regular applications of slurry, potentially post grazing or post cutting, are giving us up to a 10% yield increase over the sort of slug feeding of an umbilical system. We're learning that the fertilizers that we've all used over the last 40 years, some of them have got downsides, and we'll come to that more in a minute as we go through the presentation. Thank you. Next slide, please. So it's now becoming apparent that prilled nitrogen or urea on the soil is an oxidant, and as such, if it's not utilized by the soil or the plants, can cause carbon burn as the unutilized nitrogen in the soil literally burns out soil carbon. And there's a range of figures in research from 16 to 100 kilos per kilo of prilled nitrogen applied to the soil in terms of carbon burn. And this is one of the big areas that, as we've got much better at using fertilizer, partly from costs from a couple of years ago, we used it more specifically, we're starting to see increased soil carbon aggregation, and nitrogen and a switch to foliar feeding, nitrogen reduction and foliar feedings. There's huge potential in reducing the amount of nitrogen we use and using it a lot more effectively without burning carbon from the soil. Nitrogen locks up potassium, calcium, and boron. If you are using nitrogen where you've got a good stand of clover, the clover gets a lot lazier. Where there's an opportunity to reduce the amount of nitrogen, the clovers have to work harder. And so it becomes almost a self-fulfilling prophecy. The less you use, the more the soil starts to bring back to the matrix to work for you. From a phosphorus perspective, we know that TSP is very available for about 6 weeks, but because it's so soluble and so available, it very quickly gets tied up with calcium within the soil. And it also is very harmful to the very bacteria that can break the phosphorus calcium bond. So we're encouraging farmers to start looking at different phosphorus soils. In fact, there's work from New Zealand suggesting that going back to rock phosphate over a period of time, because it doesn't get tied up nearly so quickly, and because it doesn't damage the bacteria within the soil, has a lot better long-term gain to the availability of phosphorus within the soil. And so it's an area that we're discussing with farmers of looking at different sources of phosphorus, so that we can make what's in the soil more available. In many soils, we're looking for typically maybe 25 milligrams of phosphorus on your soil analysis to grow a good crop. There may be 1,200 in your units in your soil. So there's potentially 40 years potentially of phosphorus in your soil, but it's got locked up. And what we're trying to do is encourage biological processes to break those bonds and get that phosphorus back to you. And when it comes to potassium, muriate of potash, the potassium brilliant for the plant, for the growth, for the cycling of the plant. But the chloride, the potassium chloride, the chloride portion is not helpful. We use chloride to kill bacteria in our water systems. It stays in the soil, and this is why a lot of dairy farmers have had to use more and more bicarb over the last sort of 40 years, because the chloride is remaining within the plant and not moving on. And so maybe we consider different potassium sources within our fertilizer regimes to stop this chloride buildup. And ploughing, contentious issue. Has got a lot of people who are not fans of it, but in situations where you've got layering or compaction within the top 6 inches of the soil, in several instances we've seen ploughing air up soils, reduce the compaction, and increase earthworm numbers. But it's being used as a tool. You have to earn the right to plough. It's certainly something that you don't do every year, but in rotation as part of a tool within your farm management, it's something that shouldn't be routinely dismissed. It has its place and can be a force for good used in isolation when you've earned the right to do so. Next slide, please. So nitrogen, became known as a moron element. I would encourage you to put less on, not more on, because I would like you to avoid being a moron. We've learned a lot by from nitrogen over the last few years, but the picture is a machine there is a tow and fert, which will take prilled urea, will move it at high volume, mix it at high volume with water, and so it doesn't freeze. And mixing urea with a carbon source, be it molasses or humates, and applying it to the plant, to the leaf of the plant, people are getting up to a 50% reduction in their nitrogen use and maintaining yields. So we're avoiding the carbon burn. We're saving a hell of a lot of costs within the farm business. NOx, nitrogen dioxide, is probably one of the most harmful greenhouse gases, and by halving the amount of nitrogen, we are keeping a lot more money within our own farm systems. We've probably met characters in the press who are now growing 10-ton wheats off 74 kilos of nitrogen with a mixture of foliar and seedbed nitrogen. So the opportunity to dramatically reduce nitrogen over a period of time is huge. Another thing that we're finding that through a lot of the analysis that we're doing from Terra Pharma, we're finding that there's several elements that are essential for legumes to fix nitrogen. Molybdenum, sulfur, cobalt, boron, calcium are all part of the process, but virtually every farm that we analyze, the molybdenum level is so low that you can't create the enzyme and the enzyme pathway to fix nitrogen. So we grow lovely clover crops, or we can grow good pea crops and barley and bean crops. But if you dig them up, if you look at the roots, there's very few nodules. And if you cut into those nodules, there's not the lovely deep red cover they're looking for. So they're not working for us. They're growing a nice crop, but they're not leaving the residual nitrogen. So there's huge opportunities to reduce the nitrogen within our farming system. And that fixing nitrogen, there, I believe it's 78,000 kilos of nitrogen above each hectare. So there's a huge amount of that up there. We've just got to create the right environment to draw down some and target the bag nitrogen or the foliar nitrogen in a lot more precise fashion. Next slide, please. So these are the machines. We have 5 of these machines running over the country. They are controlled depth samplers. So typically in Cornwall, we sample 0 to 15, and well, particularly in the southwest, 0 to 15 and 15 to 30. As the carbon market matures, the ability to show repeat sampling at controlled depths and show improvements in soil organic matter through analysis is becoming more and more important. It adds to the story. We're not just a metric based on an idea. You're putting real grist to the mill. Next slide, please. And so if I were advising the TFA as a group of farmers, if and however you do your sampling, if you can GPS mark where you take a sample so that you can return to that sample that sample point every few years and sample to the same depth, so you can buy a decent core for 200 quid. On most phones nowadays, you can have a GPS setup so that you can repeat sample and manage your own depth of those sampling. You're adding to the story. You're adding to the professionalism of what we're trying to get the industry to embrace. I suggest sampling every 1 to 3 hectares. If you've got a very large farm with very little variation, maybe you can stretch out to 4 hectares. But the more data that you get, with the more accuracy of that data, will build the story for your soil carbon, will help you in your soil carbon journey, and ultimately will give you the best opportunity to achieve the highest price when that market comes for you. If you've got deep loamy soils, then probably you can go 30 to 60 centimeters, because the more depth you analyze, the more potential carbon you've got. But we do see a lot more rooting activity in the top 15 centimeters. And that's where the root exudates, the carbon is pumped down more easily. Longer term crops, herbal lays, clovers red clovers especially lucernes can go much deeper. So the more deeper you go, the more data you have and more carbon you have to discuss, but it's much harder to get carbon down to those areas. The 0 to 15 centimeter horizon, you can gain and lose carbon quite quickly. If you have a drought, if you do a lot of heavy tillage, you can lose organic carbon as well as gain it. And so please don't think that carbon is a linear thing. You have to manage it to the best of your ability to get the biggest increases. When you are sending your samples for analysis, please use the GMAS analysis. It's more expensive, but it's more accurate, especially on soils where you've used a lot of lime or you have a high calcium type soil. This is to do with the burning temperature of the sample, but it will give you again a better, stronger story and probably more accurate numbers when you come to understand if you're building soil organic matter across your farm. And this is where it gets a little bit more complicated. If you are thinking about carbon markets in the future, then it's probably wise to take some bulk density samples across your sites. There's a variation between sort of 0.7 of it. So a bulk density measures the relative weight per centimeter cubed. And there's variation between 0.7 and 1.6 grams. So there's a heck of a range. And if you take bulk densities, they do change over time. As your soil health improves, your soil bulk density may rise. It may go from a 1.3 to 1.3 to a 1.2 or 1.1. So it's important to take bulk density samples as part of your story and part of your due diligence. You may not have to do every site, maybe you do every other site, but when it comes to the market, we want you to tell the best story. Next slide, please. So some quick case studies. There's an awful lot of there's a report in the Financial Times yesterday about carbon markets and are they over-egged? But these are genuine farms that we've worked within Cornwall on a reasonably light loamy soils with livestock integrating. Very good farmers in the initial instance, but over the sort of last 4 years, we've encouraged them to look at carbon sources with their nitrogen, reduce tillage, add more diversity into their cropping and into their lays. And this interestingly with this farm, the first year, I suspect that all farmers would started with a degree of skepticism, and both quite competitive sort of ex-rugby types. But this farm wasn't quite, or certainly his agronomist wasn't quite so engaged in the process at the start of the process, and we didn't see a lot of improvement in the first year. And 2022 with us was quite a drought, so we expected to see from 22 to 23, we expected to see a drop in soil organic matter, but on this farm there was quite a jump in total organic carbon and soil organic matter over that period, to the extent that there was a potential 3,500 tons over those 3 years of carbon surplus after we offset the farm's own dairy farm business. So if you value that at £20 a ton, that's a £70,000 reward over that 3-year period, including a drought, which would have been very which we thought would be very damaging. So we had the complication, we had the climatic changes within that, and yet we still made progress. If we could go to the next slide, for farm T. So this was quite a remarkable set of data, and this farm over the period, and reason for showing both these farm graphs is that if you look at the bar graph, you can see that carbon can go up and up as well as down. Both farms were affected by the drought, but because this farm had made such dramatic increases in the first year, I think there was probably more volatilizable carbon in the soil horizon to lose, and so this did drop back. But even if you consider the drop in the third year, there's still 7,500 tons of CO2 equivalents to put into the equation over that farm after they've offset the farm business. And because there's bulk density, because it's GMAS, because it's controlled depth sampled, and we've taken these results to universities, and they've verified the sort of understanding that the protocol is accurate in assessing soil organic matter improvements, and that the methods we've used indicate that good regenerative practice results in higher drawdown. And this is the opportunity for all of us as farmers is to get as accurate data as we can, and to monitor it, to offset your own farm business, because these outputs on a light soil, certainly not a heavy soil, are very, very achievable. Last couple of slides, I think. So yeah, focus on the measurement, management, and recording of organic matter on your farm. If you do nutrient mapping with a business like us, you can also terrific opportunity to cut back fertilizer inputs. Accurate resampling will maximize the value of the data you've already collected, and you as each farm business have got to understand how long it's going to be. If it's an arable rotation, a longer sort of period of time. If you don't change anything, then probably you've got to go for a longer period of time, and you may not build organic matter. But if you track the organic matter against your own farm footprint, and you engage with some of the practices we've discussed, there is this opportunity to build another income stream into your farm business. I suggest that in your top analysis, you do your basic nutrients, P, organic matter, pH, because I think there is an opportunity to really start challenging your fertilizer use and use the biology of the soil to release locked up nutrients. And take an open-minded approach to changes. Discuss this with people like ourselves. But I'm hopeful that we'll work with the TFA and other farm outreach where these slightly obscure practices 4 years ago come a lot more mainstream, because there's opportunities to build resilience, to cut costs, and to develop another potential stipend for your business. Is that it, Julia? Oh, I got one more. Oh yeah, and a very quick slide. Several of you may be on this journey. This is a great slide to show what the potential is. So this guy started out as another disruptor like Gary Zimmer back in the early 90s. Didn't like what was going on. Didn't like what he saw. Thought that no-till was the answer. And he had so he started off at 1%. Most of the farms, the lowest we regularly see in the UK is 2 or 3%. Maybe it's 1% in the east. But a lot of soils are already higher than this. But he brought crop diversity in, went for cover crops, and he went from 1 to 2 to 2.5, which is a massive increase in soil organic matter, a doubling. But it's when multi-species cover crops and then livestock were reintegrated into that farm. And this farm is currently at 13% organic matter. So there's a massive story within livestock integration, within cover cropping, and reducing tillage, which will have a very positive outcome on your farm. And where it's possible and achievable, there's a huge opportunity for you to build soil health. Thank you. I think that's it for the slides. Yes, thank you.
Well, that's a fantastic presentation, Matt. And I know I was taught when I was in Young Farmers, when I did the public speaking or debating, what are the main things that you pick up as you go along. And you can't manage what you don't measure. Cattle are a huge mitigation tool. Mixed farming systems, huge benefit, min-till, benefit of rotational grazing. And carbon, the new income stream post BPS. So it's those are things that I've picked up, but I'm sure there'll be a lot more that other people have picked up. And I'd like to bring George in at this point when we're looking at our question and answers. And we've had a huge number of questions come in both prior to tonight's webinar and also while we've been listening to Tom's presentation. And the first one that came in is, I think it's probably for you, Tom, here. How can we have confidence in carbon calculators when there are so many different calculators out there? And especially when we're trying to get to net zero, and to give the result a true value?
My belief, there's several out there, and there's a lot of businesses offering them, but basically find the one that you're comfortable with. I mean, Cool Farm Toolkit. We work a lot with the Farm Carbon Toolkit. And a lot of supply bases have their own calculators. But once you start with one, unless you completely fall out of bed with it, it's best to keep with it, because the only way you're really going to track improvement and change is comparing like with like. It is important for us to get a handle on it, but it's more important if you start with a process and you're 2 or 3 years in, then stick with it, because and I guess also make sure that carbon calculator allows for soil organic matter, because there is potential here to build organic matter, and you've got to be able to input that as part of the process to show that you're doing good things with your business. So stick with what you've got, but make sure if you're starting out on that journey that the calculation allows for increases in soil organic matter.
Oh, well, that's good to know that. George, there's a couple of questions coming in, especially to do with ownership of carbon, whether it be the landlord or the tenant. Will I benefit at the end of my tenancy for compensation for carbon sequestration through the terms of my lease?
Yeah, hi Robert and Tom. Thanks so much for such an inspiring presentation. Yeah, I mean, I get asked very often about the ownership of carbon, and I try and split it into two, because obviously there's carbon in the soil that exists today, and there's carbon that you will generate through your practices and your sequestration tomorrow. And to my mind, the concept of who owns the carbon that's in the soil today doesn't really matter, because it exists today. The private sector isn't going to pay you for that carbon because it's already in existence. The private sector wants additionality. There might be a good reason why the state should pay for that carbon to be retained, so that people manage the ground in a way which ensures that it's not released. But the ownership of that carbon is, to my mind, neither here nor there. The real issue is who owns the carbon that you create tomorrow? Who owns the carbon that you develop and you sequestrate going forward? And I think, as Tom has ably described, that only happens because of the activities of land managers. It only gets sequestrated because people bother to change the way they do things in order to attract more carbon into those soils. So for my mind, whilst that carbon will be left behind in that soil, it is effectively an asset of the tenant, an asset of the land manager, an asset of the person who's bothered to do that activity. And those individuals should retain the benefit of it. Now, when we get to the end of tenancy, I have to say that we are not yet at the stage where the end of tenancy valuation procedures are articulate enough to deal with issues of the value of carbon that has been created over that period of time, or the potential for carbon to be sequestrated further in that management. And I know there is some work going on within the CAAV to try and bring this together. But I would have thought that if you have managed to get yourself into a position of a contract with an outside body because of your activities in relation to carbon, that value should be something that you should be able to take away. But there's more work to be done on that.
No, that's good to know that, George. It really is. I think, Tom, this one for you. This is a question from a member in Leicestershire. Having been drilling for over 20 years, direct drilling for over 20 years, we probably can improve our organic matter much more. How can we get value for this?
This is something that nearly keeps me awake at night. Because there's a heck of a I genuinely believe that you after 20 years of direct drilling, providing we haven't got too much layering going on in the soil, that you've got probably a very healthy soil with a good soil structure. What if you look read extensively into soils and things like that. After Charles Darwin wrote Origin of Species, he spent the next 37 years studying earthworms in his back garden, and in that 37 years, he created 7 inches of topsoil. Now, my challenge to myself, and I haven't worked it out now, is it in a farm situation like this man this farm business in Leicestershire, we need to understand how to ground mark. I'm very keen on the phrase sort of carbon baseline, but we also need soil baseline, because when a soil hits its terminal sort of or soil organic matter, I don't think it doesn't shut down. The biology doesn't stop. It keeps going, and what's probably doing is it's creating more topsoil and it's pushing upwards. Now, we've got farms that we know in places like New Zealand, which are creating topsoil at a rate of 1 to 2 millimeters a year. Now, this farm may well be one of those farms, and the offset and the potential increase in soil content in that sort of rate of production of topsoil is quite huge, potentially quite huge. So it's a challenge to myself and to work out how we can baseline this, because we need to record this as, again, because there is a skeptical view that farmers should plow everything before they start the process to release the carbon to put it back in again. I don't believe that. I believe you've got a healthy biology that is continually sequestering carbon and pushing upwards. And we need to be able to measure that so that we can give this guy or this farm business a true return for his good efforts, or her good efforts.
No, I think that's a good point, that actually. George, we've had a question in last week regarding from a landlord, and as a county council, we aim to support new entrants. What are your thoughts on the balance between tenancy length and ensuring new opportunities are brought forward regularly? We have 33 farms with still a few AHA and FB tenancies, lengths of 7 to 10 years.
Yeah, Robert, I could probably talk for the rest of the night on the issue of new entrants in county council small holdings and the industry, but I'll try and keep my comments brief. I think sometimes, you'll understand what I mean by when I say this, we focus too much just on the new entrant, and local authority landlords are driven to provide opportunities for new entrants. But if you just focus on the new entrant, you end up creating what I call a farming conveyor belt, because you always create opportunities for new entrants, but you're never creating opportunities for those new entrants to progress. So my view is that we shouldn't be focusing on new entrants so much, but progression, because progression will naturally pull through new entrants into the system. So if we're not focusing on that end of the spectrum, then we're just creating expectation that we can't match, because we bring people in on a 2 or a 3 or a 4 year agreement, and there's nowhere for them to go. So my view is we need to be focusing much more on progression. But looking at the sorts of things that Tom has been talking about and the way in which policy is developing, it's as clear as mud that as clear as day that we need longer term agreements. We need to have the ability for people to invest in property, to manage their property in a way which is developing resilience to their businesses and environmental outcomes, including carbon. And you can't do that on 2, 3, 4 year agreements. You need 10, 15, 20 year agreements in order to achieve that and to capitalize that properly. So I think we certainly need new entrants, but we need security of tenure, and we need to focus on how we get people progress through those tenancies.
No, absolutely so. Tom, there's a question coming here asking about what price per hectare it is to do soil sampling, please, for carbon.
It can be between, I don't know. So let me think. It would be to do bulk density. Bulk density is becoming a pain because it's a very laborious process. But I think to get accurate numbers, you've probably got to do bulk density. So it could cost between 20 and £50 a hectare, depending how rigorous you went and how much bulk density and things that you did. So what's that? To £8 and £8 to £20 an acre, something like that. So but it would help farmers in their SFI applications as well. So it might not be a complete cost to a business, and if you do but that would include your base elements: potassium, phosphorus, pH, organic matter, and magnesium. So it gives you and that for that sort of money you'd get it all mapped so that you understood what your farm looked like from a soil organic matter point of view, from nutrient mapping point of view, and would probably fit you straight into an SFI agreement, which does help in the future policy of your farm, I think.
Okay. Another quick one on here was saying that bearing in mind, we mentioned tonight how the importance of rotational grazing, how cattle can be a huge mitigation tool, mixed farming is the benefit, and yet the press tells us that cattle are the worst things in the world for anything to do with carbon. How can we explain this to the consumer in a better way?
This has been quite a joyous process over the last 4 years, because we'll go and talk to a cluster group or a discussion group, and the farmers, we talk about the press. The farmers have also been browbeaten by this whole process, and when you explain that the joy of this is, it's such a it's a triple win. You can farm in a way where you reduce your inputs, you reduce your carbon footprint, and you produce a high quality food stuff, and possibly a higher quality food stuff, by taking this process. But I suppose the indication is we a couple of times we've been asked to Eden, a big tourist place in Cornwall, to talk about agriculture, and we've usually been asked on World Environment Day, and you get a 20-minute slot, and once you start explaining to people how soil and environment and animals and good agriculture can integrate. We've often been talking for 45 minutes and taking questions because people really engage with it. They like to know the authenticity of their food. They like to understand that what they're doing can be beneficial. And this new understanding with herbal lays, with reduced inputs, with rotational grazing, with bicropping, the potential to save fungicides and nitrogen, they're all wins. You generally produce less stressed crops of high nutrient density, etc. So the public really engage with this. So it's changing the narrative, and the data that we're getting is really helping that. But it's people picking up their kids from school or when they go to friends for dinner, is starting these debates with people and explaining how important that good agriculture, good intelligent agriculture can be. And it's so important that we in the West, and I don't mean this pejoratively, where we've sort of cocked up our ecosystems, can re-engage, can bring the bird life back through these cropping systems, can reduce our inputs, and produce high quality food, because it's so important we don't stop producing food in this country to just export our carbon issues to Africa or something like that. We've really got to keep productive agriculture part of what we do, but do it in a way that can be beneficial to the environment.
No, I think if you look at the map that Tom put up in his presentation about where the carbon-rich soils of our country are, they correlate almost completely with where the livestock is in
Correct.
our
Yes.
country. And those livestock farmers are managing on behalf of the nation a huge amount, there we are, a huge amount of benefit for the whole of society by storing that carbon, managing that carbon. And the animals that graze those acres of land where that carbon exists are only recycling carbon. They're not taking new carbon out of the system. The grass is sequestrating carbon. They will consume that carbon. The carbon then gets released, but then it gets fed back into the system again. So there has been, very sadly, a narrative that beef is bad, dairy is bad, sheep are bad, but actually, in the round, managed well, in the sort of way we do it within the UK, they're good for food security, good for the environment, and good for climate change. And we need to continue just to make sure that we say those things loudly and very clearly.
Absolutely, wholeheartedly with that, George, I do. This is quite a topical piece, bearing in mind the conversation going on with the green module, red tractor and farm assurance in general. Is there any real value to the carbon to my business, or will it just become a compliance requirement either within contracts or regulations?
Can I go? Part of the passion for doing these sort of talks is the farmers have got to take responsibility for their carbon and own it and understand it. There's a huge opportunity, and farmers can offer. We're working on a system at the moment where you can prove carbon. We can offer to inset it into the supply chain, and again, once a farmer has verified surplus of carbon, he can speak to his slaughterhouse, he can speak to his milk buyer, he can speak to his sheep system, whatever it is, and integrate that into the system, and then the system can offer it to the supermarket. Dairy sits as a big carbon output on a lot of processing businesses, and the data that we're starting to correlate and explain show that we can completely obfuscate that carbon all the way through the process. It's much better that we have high quality meat and dairy products on the shelves with a very low carbon footprint than it is that MasterCard or Ryanair or something can buy a credit from us. We've got to integrate this into our system. The opportunity's there. Partly, I suspect why George and Julie have asked me to speak there is to encourage farmers to take ownership of this and responsibility, because it's their farming practice and their outputs which are driving this, and we've got to integrate it into the food chain so that, again, we can say that our nutritious foodstuffs are carbon, very low carbon impact, if not neutral, and are a very important part of the ecosystems that we live in.
Yeah, Robert, we've got to watch this one really, really carefully and be very wise about how we progress here. And I absolutely agree with Tom that farmers need to take ownership of this and to understand it and to be at front and center in terms of how they take this forward, because obviously we have processors and retailers who have got statutory commitments for their climate change targets and will have signed up to other commitments, for example, through the World Wildlife Fund basket about how they want to progress the food chain. And retailers will be trying to use their leverage in order to ensure that other people meet those commitments for them, farmers. But actually, farmers are part of the solution, and therefore they should be properly rewarded for the work and effort that they're putting in to deliver this benefit for the whole of society. And we need to find a collaborative and collegiate way to do that so that we all gain. So it's not just taken by one part of the chain. So that farmers gain, processors gain, retailers gain, and consumers gain. But that all means we all have to pay a little bit of the price to get to where we want to get to. So yes, we need to watch this one very carefully and make sure that our members do get the benefit. Absolutely
so. It wouldn't be a seminar or a webinar with the TFA we didn't touch on farm rent prices. And we have one coming here say, how are farm rents going to respond to all this value in carbon?
There's an interesting question, isn't it? And certainly, if the value of carbon does go up, which is what everybody is saying, then the more that individual farmers are deemed to be able to produce that carbon benefit for society at a value, obviously rental values could go up on the basis of carbon. But there's an awful lot of stuff that we need to do from a baseline perspective, and that's going to cost our businesses a bit to begin with. So, I think there are landlords out there who are looking at this quite seriously and are trying to assist tenant farmers to get themselves into a position of being much more focused on what they need to do from a carbon perspective, and they are looking to see whether rents could fall back a little in order to give the space for people to innovate and to move forward. But my view is that we want profitable businesses being able to pay good rents. So if carbon is a good thing for society and has value and is rewarded to our members, then I wouldn't be unhappy about our members paying a higher rent if they're getting a higher return from carbon.
Well, I think that's a superb point to bring our question answers to an end now. We've had I think anybody that hasn't had their question answered this evening, we can forward them forward at the end of tonight, and we'll hopefully try to feed back into both George and Tom on that. It's really down to me to thank our speakers this evening, both to Tom and to George, and also to our event sponsor, Oxford Bank, and we thank you for your support. Our next webinar was going to be on the 15th of February, and this is implementing the ROC Review recommendations, what has been achieved, and we're very pleased that we're going to have Baroness Kate Rock to talk to us, who is the tenancy working group chair. So look out for your invitation for that. Don't forget to log on to our YouTube channel, and if you found it very useful tonight, we hope you'll pass it on to friends and neighbours who you think maybe have benefited too. So thank you to all for attending, and good night.